So in the last class we discussed what is our Bayes theorem. Yes. So there is a possibility of one event to happen from various things. Means we take the help of our Bayes theorem concepts and we solve the problems. So next we are going to discuss what is our random variables. Okay. So why that is necessary for us is that when we are going to conduct an experiment, when the number of outcomes is a finite one, it is okay. Finite and countable means it is okay. We can easily predict that. Okay. When the number of outcomes is 4, it will be difficult for us to identify all the sample space to write it down and do our calculations. To overcome this problem only, the random variable concept was introduced. So last class I started that explanation. When you toss your coin, what is the outcome? Head or tail. What do you do this? 3 coins, 3 heads and various possible combinations of head and tail. 10 coins. But whether it will be for 10 coins. How many possibilities? Various possibilities are there. So it is difficult for us to write out all the possible outcomes and predict it. Okay. So to overcome this problem, we are going to introduce a concept called random variable. So here random variable, what we are going to do is that we are going to map all the sample space to a real number. When we convert everything into a number format, it will be easy for us. So we are going to convert everything into a number. The same example, tossing a coin. What are the possible outcomes? Head and tail. My event is that I am going to get a head. How many heads are possible? 1. So I can assign head to be the random number 1. What is the other sample space possible? Tail. Whether it will be head is there in that one? No. So for that I can assign the value to be 0. Because my event is getting a head. In my sample space, H is having 1 head. Tail is having no head. So I am giving the random value as 0. So what are the possible random values for this one? 0 and 1. Similarly, tossing 2 coins. So what are the possible outcomes? Head, 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 tail, and tail. Now we are going to convert this into a random variable. Okay. So here we introduce x to be the random variable denoting the number of heads. Again, random variable also should be written only in capital letter, like in that. Okay. We have written x to be the number of heads is there. So see the first possible outcomes. How many heads are there?
2.
How many heads in the first possible outcome?
2.
2. Second one? 1. Third one? 1. Last one? 0. Okay. So the possible random variables for my problem will be 0, 1. This is the corresponding random variables. One is it can be having 2 choices. Either it can be head, tail or it can be tail. So you are going to convert everything into the values. So that it will be easy for us to do the calculation other than with the sample space. Okay, now tell me what is the values for here for collapsing 4 points. In a number assign 4 points assign. Maximum எத்தனை heads வரலாமா? 4. 4 coin में head ஆடலாம். இல்லனா 3 coins ல head எடுக்கலாம். இல்லனா 2 coins ல இல்லனா 1 coin இல்லனா 0 head இல்லாம இருக்கலாம். So what are the possible random values? 0, 1, 2, 3, 4. Okay. So instead of dealing with the sample space, we are going to convert everything into a real number and then we are going to solve the problems so that it will be easy for us to deal with higher number of problems. So for that purpose only random variable has been introduced. So definition means what we are going to say is that we are going to map the entire sample space into a real number. That is called as a random variable. All the possible outcomes are mapped into a real number line. So that is called as a random variable. Okay, so take down. Next topic, random variable. Random variable. Random variable. So right, a random variable takes, so it should be written in capital letter. Whenever we say random variable, it should be written only in capital letter. A random variable takes yes, a real value, yes, a real value function, real valued function that maps in the sample space of the random experiment to real values. Okay, now we know what is random variable. So this random variable can be defined for any n dimension also. We can define it as one dimensional random variable or two dimensional or three dimensional or any n dimensional random variable. Because it is, we cannot always say that we are going to do the experiments only in one dimension. Okay, we can do the experiments in two dimensions also, three dimensions also. So we do the experiment in one dimension, we will be getting only one possible outcomes like either 0, 1 or 2 or 3 like that. When you do the experiment in two dimension, how will you get the outcomes? Two dimension is how we write the values. General, not for this problem. Two dimension is how we discuss the value. One dimension is what we say, either the value is x1 or x2 or x3 or y1 or y2 or y3. When it goes to two dimension, how do you represent the value? X comma y. Order pair x comma y. x2 or value of parallel y2 or y. That is what two dimension. When you go into that type of concepts, that will be called as a two-dimensional random variable. Then you can extend it for any n-dimensional random variable also. But according to our syllabus, we are going to restrict only to two-dimensional random variables. So in the unit 1, we are discussing unit 1 and unit 2. Both we will be discussing only one-dimensional random variable. Unit 3 we will be discussing for two-dimensional random variable. Okay, so in this unit, we are going to discuss everything based on only one dimension. Okay, so take our next definition. Next definition. A one-dimensional random variable. A one-dimensional random variable is defined as the random variable x which assumes single value corresponding to each outcome of the experiment. So now we know what is the way value. That's step 4. We say it as a values. Okay, so there are two types of values which is possible. We can say it as a discrete value or we can say it as a continuous value. So two categories are there, either discrete or continuous. What is the meaning of discrete? What is the way discrete? Yeah, use that one. You know that one. Yes? Discrete. Say it, Discrete na எந்த பாயிண்ட் மென்ஷன் பண்ணிருக்காங்களோ அது ஒரு பாயிண்ட் மட்டும் தான் டிஃபைன் பண்ணும். அதுவே கண்டினியூஸ்னா ஒரு ரேஞ்ச் இன்டர்வல் பாயிண்ட் எடுத்துப்பாங்க. அதுல இருக்க எல்லா இன்ஃபைனைட் நம்பர் ஆஃப் பாயிண்ட்ஸ் அந்த ஃபங்க்ஷன் என்ன இருக்கும்? டிஃபைன் ஆகும். That is called as the continuous. Why this is important is that we are going to discuss the two types of problems. One will be discrete and another one will be a continuous one. So in the exams we identify which is discrete and which is continuous and then you have to solve the problem. Okay? Rajesh Sharan accept, right ma? Continuous ma? Any doubt in that one? Okay, so take down. So first we are going to discuss everything based on discrete random variable. Then we will be discussing with the continuous random variable. Okay? But in the exams it will not be so much. You only have to identify which is discrete and which is continuous. That is also very easy to do. So in your question what happens is that if we given the set of values to be like this, a is equal to 1, 2, 3, etc. Whether this will be discrete or continuous? Why? Instead of the continuous.
Discrete.
Discrete. What I said? X equal to 1. It is going to be defined at the point only 1. X equal to 2.
2.
It is defined only at the point 2. Whether it is going to be defined between 1 and 2?
Continuous.
Whether it is defined here?
No.
No. I have not mentioned like that. ஒரு point தனித்தனியா கொடுத்தாங்கன்னா then it will become as a discrete case. When it will go for continuous is that the same thing I say x belongs to 1 to infinity. Okay, 1 to infinity means what is the meaning? Define at 1, we define at 1.01, it will define at 1.001, etc. All the in between points, then it will become as a continuous. The other way of representing continuous is 1 less than x less than infinity. Iterating continuous. Okay, so it will define between all the points between 1 to infinity. So it becomes a continuous. In simple way, if I have to say this, if I given like this, only one particular point at a time is it becomes a discrete. Either it is given in interval form or in inequalities, it is called as a continuous. Okay, easy to identify. Just remember the corresponding formulas, apply it and get solve the problems. Okay, so continue. Discrete random variable. Discrete random variable. Discrete random variable. So right, a random variable takes is said to be a discrete random variable is said to be a discrete random variable if it assumes only discrete value. If it assumes only discrete values and this can be finite or countably infinite. This can be finite or countably infinite. Okay, it can be a finite value or it can be a countably infinite value. Like we say x equal to 1, 2, 3, etc. to infinity. We don't know what is the infinite value. Like that also we can define. Now we say the basic definitions. So always we are discussing only with the chances of happening the reserved probability values. For discrete case, we are going to define the probability value as probability of capital X is equal to small x. The meaning of that one is that what is probability of capital X when it takes the value small Okay, go for x equal to 1, f of 1. What is the definition? X less than or equal to how many values are possible? P of 0 and P of 2. So the add rule. F of 2. What will answer? 3 values. What are they?
0,
1, 2. Okay, so going to add all the 3 values. Okay, only 3 values are different. There is no trigonometry linear matrix. This is called as a distribution. Since it is a discrete case, we are going to add one. When it is go for continuous case, what will operator? Not multiplying, not division. Integration. The one which we know the most, right? So no, integration process. So we are going to solve all the continuous problems with the integration process, whereas for a discrete case, just ordinary addition. So this will be an easy one. You have to put more effort for your continuous case. Can anyone identify what is the value for this last one now? If you understood what I taught you so far, you will be able to answer. For last distribution function, what will be the answer? That is a very standard one. Why? That is probability value. What do you know? Capital F of 2 is what is nothing but we are trying to find the probability value. What is the range of probability value? 0 to 1. Then how can you declare the answer is greater than 1? 1. Why? Both the more than what is not possible, so equal to 1. It can be less than 1, no? It can be 0. One point which I asked you to remember always. You have forgotten that again ourselves. If there is 10 possible outcomes is there, you have found out the probability for all the 10 possible outcomes. When you add all the probability value, what should be the answer? 1. What is the reason? Here our x is having how many values? 3 values. When we added all the 3 probability values are known. So what should be the answer for that one? 1. Always the last distribution function will be equal to 1. Okay, that is the way you can check your answer. In a 1 by 1 when you add it is like a cumulative addition. Okay, 1 by 1 you are going to add. When you come to the last value, the answer should be equal to 1. If you don't get 1, what is the meaning? You have made some mistakes there. Even the probability value what you got also might be a wrong one also. Okay, so that is the way of cross-checking your problems. Always the total probability value will be equal to 1. Using this as a gate, if it is asked in a question means you yourself can verify your problem. Okay, any doubt in these definitions? So they go. Let x be a discrete random variable. Random variable also you can write it short as small r dot small v. You can accept it small r dot small v. Let x be a discrete random variable having values x1, x2, etc. x1, x2, etc. comma. Then the probability mass function. In short, we write as PMF. The probability mass function within bracket write PMF is given by probability of capital X equal to small xi. The other way of noting that one is small p suffix I. X equal to x1 means this will become p1. X equal to x2 means this will become p2. The corresponding probability values. Next definition. The probability distribution function. Or cumulative distribution function. Cumulative distribution function is defined as capital Let x be a random variable. Let x be a random variable having the following distribution function. Having the following distribution function. X values 0, 1, 2, 3, 4, 5, 6, 7. Corresponding probability value 0, k, 2k, 2k, 3k, k square, 2k square, 7k square plus k, 7k square plus k. Written up. Let's continue the question. Find first subdivision the value of k. Find first subdivision the value of k. Second one, probability of 1.5 less than x less than 4.5 given x greater than 2. 1.5 less than x less than 4.5 given x greater than 2. Third one, smallest value of lambda. Smallest value of lambda. Smallest value of lambda for which probability of capital X less than or equal to lambda is greater than 1 by 2. Is greater than 1 by 2. Find the smallest value of lambda for which probability of capital X less than or equal to lambda is greater than 1 by 2. So whenever you are given this types of questions, first thing to identify is that whether it is discrete or continuous. Discrete or continuous? Discrete. Why you say it is discrete? It is different only at that one particular points. What are the points given? 0 to 7. So it is defined only at x equal to 0 and x equal to 1 like that. So this is discrete. Okay. Based on this one, we are going to solve all these things. For all these things, you need all the previous things what you have discussed. The basic things of probability. Okay. When you see here, you have given the probability value. Whether all of known values or unknown values. Unknown. Which is the unknown value here? K. The first subdivision they ask you to find k. Whether they ask or not, you have to find the unknown. You can't solve any problem with that unknown value. You can't find a solution. So whether it is mentioned to find k or not in any problem, whenever there is an unknown in the defined probability value, first you have to find that one. Then only you must start solving the other things. Now tell me, how do you find k? The total probability value is 1. So when you add all the total probability value, it should be equal to 1. Using that concept, we are going to solve and we are going to find what is our k value. Okay, so start the solution. So right, we know that summation of pi equal to 1. We know that summation of pi equal to 1. Summation of pi is what is the meaning? Total of all probability. How many probability values are given? 7, 8, 0 to 7. Add all the probability values. Add everything. That is 0 plus k, 2k, 2k, 3k, k square, 2k square, 7k square plus k equal to 1. Add it. Now simplify your left hand side. How many k's are there? How many k's? 9 k's. How many k square? are known. How we factorize? 10k square plus 10k minus k minus 1 equal to 0. What is forming first two terms? 10k. Take it outside. If you take 10k outside, what is the remaining? A plus 1. What is forming the next two? Minus 1. So take minus 1 outside. Remaining will be a plus 1. What is forming both now? A plus 1. So k plus 1 into 10k minus 1 equal to 0. Now you have to find k value. Equate each one to 0. So what happened? K plus 1 equal to 0 implies k as
Minus
minus 10k minus 1 equal to 0. So what we get? 1 by 10k equal to 1. So k will become 1 by 10. Okay. Now we got two choices of k value. Which will be the right one? Minus. Is it or minus? Probability of x greater than 2. Now, you identify each of these probability values correctly. What is the numerator mark? 1.5 to 4.5. Just for understanding and writing the real line, if you can identify directly, means no issues. 1.5, 2, 2.5, 3, 3.5, 4, 4.5. Okay, well, these are the values as it is written, since it is given as 1.5 to 4.5. But whether in our case all these values are there, x is the values in our paper. How the x is defined? No, our original x. 0, 1, 2, 3, 4, 5, 6, 7. Integer values only is defined. So whether we may have a 1.5, whether we have a 2.5, 3.5, 4.5. Okay, all those decimal values are ruled out because we are defining only for the integer values. So this is the positive values in our numerator. 1.5 to 4.5. It has three positive values. Either it can be 2 or it can be 3 or it can be 4. Okay, for this is positive values. What is the next condition given? X greater than 2. X greater than 2 is only positive value. 2 to 7. So for the second case, what is the positive values? 2 to 7. Now we have to get the intersection of both. How many values will be there in the intersection? Common terms. Intersection is common terms. Okay, well, even positive values only 3 points. 2, 3, 4. What are the positive values for this one? 2, 3, 4, 5, 6, 7. All the values. What is the common point? 2, 3, 4. Why 2? 3, 4. Greater than 2. Greater than 2 is what you have to do it. 3 and 4. Can you understand others? So we are actually out. Can you understand this one first? 1.5 to 4.5, how many values are there? 3 values. What is the condition given here?
Greater than 2.
They say that the original question mark, don't mix with this one. So what are the positive values for x? 0 to 7 is the greater than 2 is only positive values. 3, 4, 5, 6, 7. Okay, so in one set we are having 2, 3, 4. Another set we are having 3, 4, 5, 6, 7. Okay, these are the positive values for this one. What is the symbol given here? Intersection. Intersection is what you are finding. What is the common point? 4. So this numerator is going to have only 2 points, x equal to 3 and x equal to 4. Can you understand? Yes. So this is equal to probability of x equal to 3 plus probability of x is equal to 4. Divided by. Then the denominator. Greater than 2. 3, 4, 5, 6, 7. So denominator will be probability of x equal to 3 plus x equal to 4. X equal to 5. X equal to 6. X equal to 7. Okay, you already know your probability values, substitute and take the answer. If here we have choice now, A is solved in this 1 by 10 replacement or you solve with K, finally substitute here K value. Your choice of solve. So what is the answer for x equal to 3? X equal to 3, what is the answer? 2. X equal to 4? 3K. So what is 3K plus 2K? 5K. So my numerator is 5K. Divided by denominator. From 3 to 7 we have had. Okay. So 3 plus 2 will be 5. 5 plus 1 will be 6. So 6K. Plus. How many K's per unit? 10 K's. That's all. But addition will be easy. That will be 1 by 2. Now we can substitute the value for 1 by 10 and take it. Okay. This simplify formula is all very well. Okay. We are going simplification formula. You should not make any mistakes. Only if you know the simplification steps properly, do it. Otherwise, what is a simple way? Take extra calculate and solve and get the answer. That's it. Okay. So what is the replacement? 5 into 1 by 2. Divided by 6 by 10. going to get full marks in your problems. This is a possible 8 mark question in your grade 1. If this like as transfers instead is for 8 marks. If you are lucky means 2 more submissions may be given and it will for a 16 mark also. If you are ready. Should I continue the third one? We have completed the answer is 5 by 7. Third one, what do you have to find? Find the value of lambda such that probability of capital X less than or equal to lambda is greater than 1 by 2. Okay? Before finding lambda, you understand what is given. What is the notation given for you? Probability of capital X less than or equal to lambda. This indicates which definition mark? Say louder. The probability of capital X less than or equal to small x. Say louder, no? What definition? Cumulative distribution function. Wherever you come across probability of capital X less than or equal to small x, it indicates the corresponding cumulative distribution. So define this lambda using here cumulative distribution function concept. In a we don't know for which x value is going to be greater than 1 by 2. Because we have covered all the possible x values. Capital X less than or equal to small x. And in this small x, then 1 is greater than 1 by 2 or greater. So define it for all the possible values till it becomes greater than 1 by 2. Okay, so third subdivision, distribution function. Third subdivision, distribution function. Third one, distribution function. Okay, first one, write down this one. Third one, distribution function. What is the first possible x value? First x value, 0. So first we have to find f of 0, which is probability of capital X less than or equal to 0. That is the definition. First, is the code visible? Yes, x less than or equal to 0. How many values are there? 0 is 0. 1 is 1. So this is the same as probability of x equal to 0. X equal to 0. What is the probability value? 0. Okay, what is the target mark? The value should be greater than 1 by 2. That is the condition. So whether this is greater than 1 by 2? No. Go for x equal to 1. F of 1. Probability of capital X less than or equal to 1. Less than or equal to 1 means 0 and 1. Like 2 take condition. First you take only 1 value. Next step you take next 2 values. So what is 0 plus 1 by 10? 1 by 2. Okay, well. Yes, whether 1 by 10 is greater than 1 by 2? No. Go for f of 2. Probability of x less than or equal to 2. Less than or equal to 2 means? What we have is 0, 1. Already know 1 by 10, add the next values. So 1 by 10 plus 2 by 10 will give you 8 by 10. Okay, so let's make a cumulative frequency now. Take out. Let's start with the next one. When it is greater than 1 by 2, 1 by 2 will answer now. So 0.5. It should be greater than 0.5. When it is to be greater than 0.5, having calculated again, what is 3 by 10? 0.3. When it is greater than 0.5,
No, ma'am.
go for the next one. F of 3. Probability of x less than or equal to 3. So with 3 by 10, what we have to add? X equal to 3. So 3 by 10 plus 2 by 10 will give you 5 by 2. That is greater than 0.5.
5.0 equal.
It is equal to 0.5. But what is the question given?
Greater than 0.5.
So go for the next one. So x equal to 4. Probability of capital X less than or equal to 4. So you have to add up to 4.
8 by 10. 8 by 10.
0.8.
0.8.
When it is greater than 1 by 2, when it is stop or proceed. Stop. Proceed பண்ண எல்லாமே greater than 1 by 2 தான் இருக்கும். But what is our question? Find the smallest value of lambda. Even if I go for x equal to 5, it is greater than 1 by 2. X equal to 6, greater than 1 by 2 equal to 2. But what is the thing we need? Smallest value. So which will be the smallest value? 4. X equal to 4 will be the smallest value. Okay, so write a definition. The smallest value of lambda capital X less than or equal to lambda given in the question. Probability of capital X less than or equal to lambda is greater than 1 by 2. Greater than 1 by 2 is 4. Is 4. If you are asked the question as greater than or equal to 1 by 2, what will your answer? 3. Because at x equal to 3 is equal to 1 by 2. Okay. Since it is asked only for this point, we stop now. If it is asked to find the distribution function, means we will find for all the values. So what will be f of 5? How do you find f of 5? 8 by 10 plus 1 by 1. Then you can find f of 6. When you find f of 7, what should be your answer?
1.
1. This is the last value. For this last value, we are adding all the probability values. So surely for f of 7, what is the answer in this game? 1. Can you understand now? Don't forget these points. If there is any absurd answers in your experiments, negative marking will be there in your paper. Okay, these are basic things which you should never forget. Okay, let's stop after this one.
Thank you, ma'am.
Thank you.